Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with episode number 50 in our live shop talk. So we are live. And are you guys ready to rumble? Okay, man. Where are you guys from? Let's see. We've got Peter from Los Angeles. We've got LOL Kid from Australia. Code Cage from from Atlanta, Georgia. We've got, let's see, where else? Eel from Israel. Okay, and I am broadcasting from the jungles of Africa. What I'm going to need you guys to do is pour yourself a nice strong cup of iced coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. Okay, and I need you to get ready to learn some cool new stuff. What we're going to be doing today is we're going to be talking a little bit about artificial intelligence, all right? And so I want to see if you guys have any interest in learning artificial intelligence. Also, I want to give a wave to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. If you guys are not helping out yet, think about hopping on over to my Patreon account and hooking a brother up. So I want to give you guys a wave. But enough of this shameless self-promotion. Let's jump in and let's talk about what we're going to talk about today. We are going to talk about artificial intelligence. Whoa, look at that. It's the virtual me. I think I better switch back to the real me. Okay, I am going to switch back to the real me here, and let's just see if I can get back over there. And I will come over here and like this, and voila. It's your old friend Paul McWhorter in his well-known orange shirt. Okay, what I did was I just was giving you a little preview of some of the cool stuff that we can do with artificial intelligence, and just wrote some simple little programs there that I thought you guys might be interested in. Okay, how many of you guys out there are working with me on my Python lessons? We went through, I think, 20 lessons on Python, getting all the way up to doing some pretty advanced things like classes and methods and threading and so forth. And then last Wednesday, we actually jumped in and started working on how to do 3D graphics and animations in Visual Pythons. And are you guys following along with me on that? Are you guys interested in the Python stuff? I want to kind of see if my audience is actually interested in Python. Okay, we've got Rinko. Okay, Philippe says he likes it. Charles, hello. Ian, VPython is interesting. Oh, good. Charles, hello from Australia. Eyal says he likes it. Code Cage is following it. Magnus thinks the Visual Python is pretty cool. Okay, because guys, I don't want to just be in there just doing kind of drive-by shooting on my lessons where I show you this or I show you this, and my audience are just random people that are tuning in to get a little quick view of how to do a specific thing. I want to kind of have my lessons build on themselves, and I want to have some synergy between the lessons. And so what we did is we spent some time learning Python, and now we're learning Visual Python, where we can do graphics and we can do animations, and all that is going to fold back into our Arduino lessons, where we'll be connecting the computer up to Arduino, and Arduino will be talking to VPython, and then VPython is going to come alive as the animations and the graphics are going to be controlled by environmental data that's coming from the Arduino. So all that stuff that you learned in Arduino, that's going to be sent to Python, and then that's going to animate 3D animations and graphics using Visual Python. So you see the stuff we're learning in Visual Python is going to build on the stuff that we learned in Python, and then that's going to tie into the stuff that we did in Arduino. And now what I think would be interested is to fold into that some artificial intelligence using Python. And so then we could have the Arduino, we could have the Python, and we could have artificial intelligence all working together. Now, I did do a series on artificial intelligence for the Jetson Nano. A couple of things there. One is you had to buy the Jetson Nano board, and a lot of people just kind of didn't do that. So not everyone followed that. So what I would like this series to do that I'm thinking about, I'm trying to kind of bounce this off of you. I'm kind of thinking about doing a class that I would call a series that I would call Artificial Intelligence for Everyone. And it would be designed to run on a Windows PC and run under Python. So you don't have to go out and buy a new board, and it would naturally fold into the stuff that we're already doing with Visual Python. It would be a new series, but it would complement what we're doing with Visual Python. And I kind of thought that that would be neat. And then, since we're already going to be talking, as part of this, going to be talking to the Arduino, you could have the Arduino sort of feeding data to a Python system that is running artificial intelligence. And so I will be asking you, and I will be looking over at the chat box, whether you think that it would be interesting to have a series called Artificial Intelligence for Everyone based on Python and designed to run on a Windows PC. So give me some feedback. Okay, Dang Dong said he really liked the Jetson Nano. Okay, I've already done that series, and some people got a lot out of it, I think, but I'm looking for maybe doing something on Windows. Hey, Cap, welcome. Okay, hey, Cap, you're from South Africa. How are things going over there? I hear that it's kind of rather tense times in South Africa right now. Hope you guys are staying safe. Okay, Raul says yes. Philippe says it sounds good. That's good. Okay, Magnus likes it. Charles, hey, it looks like we're getting some pretty good feedback. Code Cage says interesting. Manuel says no Windows. I'm sorry, man. Manuel, I hate Windows as much as the next guy, but it's kind of like a Windows world, and we're just living in it. And so at some point, we kind of got to do things in Windows because that's what everyone else is doing. If it were me, I would just move to Linux, man. I love Linux. There's a couple of things that hold me from not just erasing my Windows operating system. One is like these live streams I do using Wirecast, and Wirecast does not have a Linux version. I know that there's open broadcast software and it works pretty good, but it just doesn't have some of the things that Wirecast does. And so Wirecast is keeping me on Windows right now. Okay, but yeah, I kind of hate Windows as well. Okay, looks like we are getting some pretty good feedback on that. Some pretty good feedback. Okay, will Raspberry Pi 4 work with your tutorials? Okay, if you wanted to work on the Raspberry Pi 4, what you could do is you could go over to my Jetson Nano lessons. And those are sort of Linux lessons. And you could probably make it pretty far on a lot of those lessons on the Raspberry Pi 4. So that would probably work pretty well. Hey, you know, I showed you this little artificial intelligence program that I worked sort of as an intro. I can try to go back over to that. Let's see if I can fire that thing up again. I do believe it was right here. Let's see if I can fire this thing up again. And I think that I can come right here and then maybe see if I can get out of your way. And so basically what you can see is this is an artificial intelligence program that is looking at the data coming from my camera, and it is doing facial recognition, and then it's creating contours of my face based on the images that it is getting off of my webcam. And it can also recognize my hand. Let's see if this would, I'm trying to, okay. Hey, Philippe, man. Oh, wow, Philippe, really appreciate it. You guys that are helping out with the Super Chats and the Patreon and so forth, really appreciate it. You know, I've had some real expenses getting my equipment over here. There's some more equipment that I need to buy. My internet is really expensive over here. So you guys that are helping out, really appreciate it, because it, in fact, keeps me out of trouble with my wife for spending so much money putting these videos together. So really appreciate you guys for helping out. So anyway, what you can see here is we are looking, hey, Griffin Bonner, appreciate it, much appreciated. What you guys can see is that I can recognize a face, and I can put face contours on and also recognize a hand. You can see in real time I can go 1, 2, 3, 4, 5, and it is finding all the little joints in the hand. And so I think that is pretty cool. Let's take a quick look at this code here. I think you can see it, and you can see that a lot of it is just very much our old friend Python. There's 58 lines of code to do that animation where I'm recognizing and mapping contours on the face. And what you can see is that it's not really 58 lines of code because there's a lot of comments in there and a lot of blank spaces. And so it's really not that hard. Just some other sort of quick demos of things that we can do with Python and artificial intelligence. Let me see if I can launch this one, and then let me make sure that you can see it. Okay, what this is this is just the raw image coming from the webcam. And then let's see if I can find this one. Then what this one is this is taking the frames from the webcam. It is finding the face. It is mapping the face. Then it's looking for the hands, and it is finding the hands. And it can, in fact, find both hands. Okay, I can think about it a little bit. I can ponder the situation. Okay, and you can see that it is actually finding and mapping every joint in the hand and every finger. And then down here you can see that we've got the wrist. And so that is, in fact, let's look and see here, that is, in fact, for that 58 lines of code. And so this is something that I can teach you how to do. Very distracting echo in my feed. Okay, let's see what could be causing that echo. Okay, I am not sure what would be causing the echo. I don't know if I have two microphones on or if it's okay, two echoes. I got two microphones on. Thank you guys for telling me that. Did it go away now? Has it gone away? Let's take a second and see if we can figure it. That is just one. Okay. Okay, it's fixed. So, guys, I apologize. One of my other windows had a second microphone going. So there was a bogey audio channel associated with one of those backgrounds. So, okay, sorry about that. Sounds like we got it fixed. I'm glad I saw that in the comments. Okay, so what were we in fact talking about? We were talking about 50 lines of code, and we were talking about being able to do this, facial mapping and hand mapping using only 50 lines of code. What is my microphone? I am using the Yeti Blue microphone here, and I've got to tell you guys, I am just grieving and miserable. I miss my silver microphone. You remember all those lessons we did where I had the nice blue Yeti gray silver microphone? Well, I left that 12,000 miles away. It is 12,000 miles away back in Texas, sitting on my desk. And what I did was I didn't pack it because all I could bring was 4 suitcases. And then I just ordered this one and then had it shipped over here. And audio-wise, they're the same, but I just thought it was so cool having that kind of silver microphone that you could see there. So I miss my silver microphone. But I digress. Okay, so what we're talking about is we're talking about some cool stuff that we can do using the most excellent Python and 50 lines of code. And then here we go. Okay, hopefully you're not getting that annoying audio again, but then you can see, you cannot see that. You know what I need? I need someone in the control room. That's what I really need. I need someone in the control room. Let me make sure this doesn't have audio. Okay. I think that's all right. Okay. And then I will get out of your way. Okay. So you can see that I can map every joint on every finger. I can map the wrist, and then I can map a facial contour using 40 lines of code. Now, why would this be interesting? Well, this would be interesting that I have access to all of this data, but I also have access to the individual points. And so I could monitor the position of my fingertip, and I could monitor the position of my eye. And as I'm just sitting here working throughout the day, I could take the distance between the fingertip and the eye, and then I could give an audible warning if you were fixing to rub your eye. You know, in these days of the dreaded virus, you're not supposed to touch your face. Well, you could just have a little workstation webcam that as you're working, if it looked like you were going to rub your face before you got up there, it would give you a beep to warn you not to do that. Because really, I think one of the number one ways you get the dreaded virus is by touching your eye. I think that the pathway to viruses into your body a lot of times is through the eye, and a lot of times we sit and we rub our eyes, and you touch something, you get something on your finger, and you rub your eyes. So you could make a little thing that sat there and warns you, gave you a beep if you were going to look like inadvertently touch your eye. And so, okay, let's quit out of this program. Let's see what else we have here. Let's look at example number 3. I just wrote some quick programs this afternoon to show you some stuff that you can do without too much trouble. Could you do sign language to the camera and have it figure out what you're saying? Big boggy face, yeah, you really could do that. Okay, now what you can see that I've done here is I've actually mapped the contour back onto my face, and then you can kind of see the wireframe of the hands. And again, I have individual access to each one of these data points, and so you end up with an array, and that array, each one of those little red dots and each green dot on my face has an X and Y value. And so like, you know where your eye is, you know where your nose is, you actually have data points for your ear, for your mouth, and so you can do things. Like, could you do sign language? Yes, absolutely, because you see from this, like, it works whichever direction your hand is in. Let's see if it'll do, yeah, even the upside down hand. So you see, you can kind of figure out in real time. It also gives you an estimation of Z, and so it's not just a two-dimensional image. It gives you a Z value and knows if you're coming towards or away from the camera. And probably it knows like a typical distance between 2 points on your finger, and as you're getting closer, that distance is getting larger, so it's perceiving that you're getting closer or further away. And so you could go in and start analyzing this wireframe on the hand, and you could have something that would actually read sign language, and then you could imagine you could also have something that would generate sign language. So one could imagine a little app that would be able to communicate with the hearing impaired for the phone, and I would be surprised probably if someone hasn't already done that. But I think this is just pretty cool here, and then we will move on, and I think I've got like another demo here that I put together, and that would be the most excellent example number 4. And what we'll do here is we will fire this one up. Oh, okay. And what this shows is you can, besides the face contour, you can come in and you can do a full body contour. So as you see now, I've got data points on my shoulders. I've got data points on my elbows. And then here, let's see here, you can see is the elbow, and then the wrist, and then you have like a little 3-point representing the hand. And so the body pose comes up to the hand, and then I'm also running the hand pose, and I'm also running the face pose. And let's see, I'm wondering if I can turn the face pose off. Let's see. I really shouldn't try to program in real time here because it usually leads to disaster. But let's see if I can turn off that face pose. Face connections. Let's see if I comment that out. And then let me comment this out. And I'm gonna comment out the hands too. Don't worry about all this stuff. It makes a lot of sense when I actually explain it to you. Okay, so you see now this is not the face contour that I'm showing you here. This is the whole body contour, and it has a couple of points for the face. You see like your mouth, the tip of your nose and the extent of your eye. And so that tracks pretty good. And then it has the whole body. Now, I could back up and I could dance for you, but I don't think you want to watch that. Yeah, I'm not going to be busting a move for you. I have no moves, all right? Now, I have this brain with this kind of unusually large portion for math and analytics and science, but as that part of the brain seemed to be a little bit larger than normal, it seemed to kind of crowd out the part of the brain normally dedicated to coordination and things like that, balance and coordination. So a lot of math, not much balance and coordination. So I will not be busting a move because I do not have a move for you, but you can see that we could track the whole body. And I don't think that I could scoot back far enough for you to see that it gives you your waist, your knees, your hips, your ankles, and your feet. It gives you a whole body thing. So you could really analyze some pretty complex motion there. Okay, so I think that is pretty cool. Yeah, Vaughn, that's exactly like reading your body motion for robot control. And so like even here you could imagine something even simpler, like if you just tracked the hand position, like if you just sort of zoomed in on a finger and you sort of controlled, like let's say that you controlled a couple of servos based on what you were doing with fingers. Okay, and also if you think of this fingertip and this fingertip, again, that's an XY coordinate for that little red dot and an XY coordinate for that little red dot. And so you could have something happen as those dots were coming together or moving apart. Like you could imagine drawing a box or drawing on the screen just by tracking those finger positions. So as you start thinking, it gets pretty exciting, especially if we're passing this data down to Arduino, which might be then controlling stepper motors or might be controlling servos or something like that. Okay, can I do this on my Jetson Nano? I don't know if you can do it on your Jetson Nano. Actually, this exact thing, Jetson Nano, you can do pose on, you can do face contours. On the library I am using right now, I have not actually installed, there's a Linux version of it, but I've not installed it on the Jetson series yet, but I will be trying to do that. We can make a following drone. Okay, that's an interesting idea. What is the Python library that is helping you? It is called MediaPipe, and that is something that I will probably be including in my lessons because it does some pretty cool stuff. And let's see here. Also, you can do things besides just look at your face. You can try to find and track things. And so let's see. Okay, you guys can see that. Let me see if I can scoot back here. It's always a little bit scary to do these things in real time here, but look at that. This is my shoe. And you see it's not only finding the shoe, it's tracking in 3 dimensions, not just the position, but the orientation of the shoe, okay? Don't hate me because of my shoe, okay? Don't hate me because of my shoe. Here's a different shoe. Let's see if it'll find this. This one is a little bit harder for it to recognize. I think maybe because it doesn't have a shoelace. There it goes. Okay, let's see if it recognizes the bottom of the shoe. Okay, yeah, it's kind of recognizing the bottom side. Okay, so you see you can find things, and you can identify things. This, there's these models out there that will find and recognize different things, and so that's pretty cool. So let's talk a little bit about this. There's sort of different strategies that you can use, and I've gotten different feedback from you guys, but let me kind of tell you what the different strategies are that you can use in artificial intelligence. One is to start from scratch and learn things like TensorFlow and PyTorch and Torch Vision, and those are very basic artificial intelligence engines. And then what you can do is you can train those. And then if you start absolutely from scratch, what you can do is maybe make something that would recognize digits. And so like you would have handwritten digits 0 to 9 and a bunch of people could write them a bunch of different ways, and you could create kind of from scratch an artificial intelligence system that could read the characters. Okay, that's something that would be done starting from scratch, and then you would learn the ins and outs of something like TensorFlow or PyTorch or Torch Vision. Okay, the good thing about that is you're learning really at a very, very fundamental level. The bad news is if you start there, you're never probably going to get to the point of being able to do something like facial detection, where you see there is a face, or facial recognition where you know whose face it is. Because for those things, what you need to do is you need to start with some pre-trained models. And so as much as I like doing things from a fundamental level, I think it's a lot more interesting if we kind of start at a higher level and use some of the existing pre-trained models. I show you how to use those things, and then we use them, and then we communicate with the Arduino, and we interact between artificial intelligence and the virtual world, which we'll be doing in Visual Python, and the real world, which we'll be connecting to through the Arduino with sensors and actuators on the Arduino. So I think this idea of virtual world, real world, and artificial intelligence world all kind of working together, I think that's pretty interesting. And you know what? We will never get there if we start at the very basic PyTorch level. So what I will be starting with is some of these pre-trained models that are already out there. And I got to tell you, some of these pre-trained models, they trained them on millions and millions of images and spent hundreds of thousands of hours on high-end computers doing the training, and we would never be able to train something as well as these pre-trained models that exist out there. Now, what we can do, we can take one of those pre-trained models and we can retrain it on a data set that we're interested in. Like, I took one of the pre-trained models and I retrained it to recognize single board computers, and that was one of my Jetson Nano lessons, where you could put any single board computer in front of the camera and it would tell you which one it was. I did not do that from scratch. I started with a pre-trained model and I retrained it. Okay, so that is sort of what I am thinking, because I just think that if we start with the core PyTorch, we're never going to get to anything that is all that really neat and cool. And maybe someday I would do a more fundamental lesson, but that is not what I am thinking about right now. Okay, guys, I've got the disappearing glass here today. Tell me what you think about this. Mr. Nimbus, thank you so much. I really appreciate you guys with the super chats. Again, I've had a lot of expenses here on the channel, and so the help you're giving me is very much appreciated. Okay, Cap Electronics says he and his family are okay. He and his family are in South Africa, and they're crazy things right now, and we were actually warned they would come to our area, but luckily we're safe. Okay, Cap, we'll have you in our prayers for safety, because I know things are always a little dicey in Africa, but it seems like somewhat unstable right now in South Africa. So hope things will calm down there. Okay, please upload the codes for you used in your programs. Man, Mohammed, I don't upload my codes because I want to teach you how to code. You know, you can't go through life just copying and pasting. I'll teach you how to do this, but I don't want you to copy my code. I want you to learn how to code, okay? I'm not, hopefully, Mohammed, I'm not sounding harsh. I didn't mean to be harsh on you, but just understand I teach you how to code, and that's why I don't post my code. Okay, Gary, welcome to a live session. Great to have you. Opal, one of our regulars. Always good to have you, Opal. And then Mohammed is currently learning Arduino. Okay. How can you make your own model? Okay, that's kind of hard. That's beyond the scope of what is easy to do. And yet the models often have odd bases. Okay. Python is actually slow. Okay, yeah, let me tell you, for the things that I am showing you today, if I just run these programs, they run really, really fast, okay? The problem is I am running Wirecast, and Wirecast is insanely graphics intensive. I have like 25 shots that are set up in my Wirecast studio, and so that is really sucking all the life out of my man. Joaquim Urbina, thank you so much. Really, really appreciate it. I'll tell you, you guys are most generous today. Really, really, really much appreciated. Keeps this great content coming. So that is very much appreciated. Okay, so the reason these demonstrations I'm showing you are a little bit choppy is my Wirecast Studio is sucking the life out of my graphics card to keep all these shots and this live streaming and all this sort of stuff going. And so then my programs run a little bit choppy. If I'm running these programs without trying to do a live stream on the same computer, they run perfectly smoothly. So I think we should be able to do some interesting things. I think we should be able to do some interesting things just running on Windows machine with a reasonable processor. Okay, I'm in Richards Bay. Was amongst. Okay, we got several people from South Africa here. All right, wow. Hope you guys stay safe. Will this require a good computer? Mine slows down as soon as I do anything complicated. Even VPython slows it down. Okay, Big Boggy, it will take a little bit of a processor. These things will run and they will work. It's just a question of how many frames per second you can get. If you have a computer that's slow, you will be getting the same learning happening that anyone else will. You just will be displaying your program will be running at a lower frames per second than the guy with a faster processor. Okay, so that will be what will happen. You'll be able to run it, but it might run with fewer frames per second on your machine. Okay, so we've kind of run through the demos there. What I want to do is, I think a lot of times when people hear artificial intelligence, they think, wow, this is just crazy complicated. So let me just kind of show you a little bit about what an artificial intelligence program would look like. And so I'm going to create a simple little program here. You guys cannot follow along this live stream at home because you don't have the libraries installed that I have. But I just want to write a simple program just so you see this isn't as hard as you might think. So I will just call this, where am I over here? I need to add a new program, and I will call this AI demo.py like that. All right, and now let me see if I can come over here. Man, I need someone in the control room. You realize that? I need someone in the control room. Okay. So let me show you just kind of how you would do a simple little start to an artificial intelligence program. So what I'm going to do is I'm going to be using OpenCV. So I'm going to import CV2. And don't try to do this because you probably don't have OpenCV on your computer. Don't try to go install OpenCV because you're going to end up with a version different than what I'm using. Just be patient. Let me do the lessons and then you can follow along. But then, okay, so what I've done is I've imported the library. Now what I need to do is I need to create a camera object. So I'm going to call my camera object my cam. And what it is going to be is it will be CV2, which is my OpenCV program. And then what I will call it, or what the command is, video capture, and then I want to capture it from port 0. And so what this will do is 99 times out of 100, this will go out and it will grab your webcam. If you have more than one webcam, the first one is going to be cam 0, the second one cam 1, the third one cam 3. And so this little number here just controls which webcam you connect to. So I'm going to have my cam is CV2 video capture frame 0. Now, you got to think that webcam is throwing frames at you. And if it's throwing frames at you, you better be ready to what? You better be ready to catch those frames, and there's going to be more than one frame coming at you. So you need to do it in a loop. So you need to say while true, when is true, true. True is always true. So this will be an infinite loop. And then my command is going to return two variables. I'm going to throw the first one away because it's not useful to me. So it'll be underscore. That's a throwaway variable. And then it's the second variable that I want. And I'm going to capture that array in a variable I'm going to call frame. And then this is going to go to my object, my cam, and it's going to read my cam. Okay, so it goes out to my cam, which is my webcam. It's going to grab a frame and it's going to put it in the variable called frame. Does that make sense? It is going to put it in the variable called frame. And then what am I going to do? I am going to say CV2. I'm going to leave some blank lines there. Then I'm going to say CV2.ImShow. So I want to show my image. And what do I want to do? I want to put it in a window called My Webcam. That's just going to be the name of the window. And then I am going to show what? I am going to show frame, like that. Okay. And let me make sure you guys are seeing that. Yeah, I think you can see that. I think you can see that. I need 2 more monitors. I need 2 more monitors. Something terrible. Okay. All right. And that got in your way. All right, I think you can see what you need to see now. Okay, so what do? I'm in an infinite loop, and I'm going to what? Grab a frame and show a frame. Grab a frame and show a frame. Now, there's one little bookkeeping thing that I need to do. I need a graceful way to exit the program, because if you just bluntly kill the program, you might still have that webcam port tied up. So what you want to do is you want to exit cleanly. So what I'm going to say is if CV2.wait key, so this is going to wait for a key press. How long will it wait for a key press? 1 millisecond. So it gets here, it pauses 1 millisecond just to see if you've pressed a key. Okay, and then if that is equal to, I'm going to quit on a Q. So I want to look for the ordinance value of Q. Okay, so if this sees a Q pressed, then if this sees a Q pressed, what is it going to do? It is going to break out of that while loop. And then when it breaks out, what I want to do is I want to my cam release. And this way, I could run the program again. Otherwise, I could lock up the camera, kill the program, and the camera stays locked up. So this is just a little clean way that you can kill your program and make sure that your window is still, that your camera is available for the next go around. So let's go ahead and just run this program. It's what, like 8-9 lines of code. Ooh, and we got an error. Wait key. You know what? Look at this. Uppercase K. We use the old bumpy font here. Hopefully this will work now. Okay, so hello, there it is. Again, it's a little choppy because of the resources I'm using for Wirecast, but you see in a couple of lines of code, we grab a frame and show a frame. I think just on its own, that's pretty neat. Let's see if I can kill it with Q. Yep, Q killed it and it released the camera. All right, now that's not all that exciting, but I want you to see that you grab a frame and you show a frame, and we're operating at 30 frames a second. And you've got to think that your microprocessor is running at like gigahertz. And so you've got a 30th of a second between reading a frame and showing a frame. In computer years, that's like the age of the universe. It's like you have an infinite amount of time between reading the frame and showing the frame to do all kinds of mischief. And it is this area between reading the frame and showing the frame that all your artificial intelligence happens. So you can read the frame, you can pass that frame to various artificial intelligence engines and processes and functions, and then get a result back, and then you can map that result back on your image. And I think that is just pretty cool. That is just pretty cool. And you can see that we are well on our way to doing a little bit of artificial intelligence here. Okay, so like what is something else you could do? Well, just to show you can start manipulating things. Like one thing is I could change the resolution of the camera. So I could say my cam, and I could set it. And then I want to set the horizontal, which is the parameter 3. And I can set that to 1280, okay, and then I can do a my cam dot set, and then 4 is the, did I say that right? 1280 is the horizontal and 4 is the vertical, and that's going to be 720. And so here I am going to change the resolution that I grabbed the frame at from the camera, and there you see that I've got a bigger frame. So you see I can control the resolution of the image that I grabbed from the webcam. Now I've got to use one of the supported ones. You can't take a low resolution camera and magically generate a high resolution image, but you can get the image size needed for your application. Another thing, just showing you kind of the simple things you could do, like I could do CV2 after I show the frame. I could do a move window, and which window do I want to move? I want to move my webcam. And where do I want to move it? I want to move it to the corner, which is 0, 0, which is row 0, column 0, because it seems like when you do an I am show, it kind of puts it in a random spot, so you can move it up to the corner. And let's see how that looks. Yeah, like now you see we have it in the corner, or we could move it wherever we want it in the screen. Like a lot of times we'll have a bunch of windows, and then you can make them smaller, and you can just sort of stack them up across your screen so that you can kind of see, as you're doing the artificial intelligence, see how things stack up. You can also do like manipulation of the frame. Like what I could come in here is I could come in and I could say that gray is a new image, and it's going to be CV2.convertColor, CVT color. And then what do I want to convert? I want to take frame, and I want to do CV2.color underscore BGR for blue, green, red to gray. And so I'm taking that frame and I'm changing it to a grayscale image. Okay, I'm taking that frame and I'm changing it to a grayscale image. And then let's go ahead and let's, you know what I'm going to do? I'm going to change this back to 640 by 480. Let's go, why not? Let's go 320 by 240. You guys keep the ratios right. Don't do a crazy ratio. It does this quickly, but if you create a strange ratio, then it slows it down because it tries to recompute that image every frame, which you don't want to do. So now what we should do is we'll still have a color image, but it should be small and up in the corner. Ooh, what did we do wrong here? Frame comma. 2 parameters. Okay. What is this? 8. Why does it not like that? This has got me somewhat perplexed. Gray is equal to CV2.CVT convert color frame CV2. Oh. Yeah, thank you guys saw that. You know what? It turned blue. It turned purple, so I thought that it recognized it. Okay, so now let's try it. Boom. Okay. You see, there's the little version of me. That's 620 by 480. Okay, I don't like that very much, but somewhere I went back to 640 by 480. I just cannot take that. So it would have been 640 by 360. And so this I'm going to make 180, I think, and that should be a correct one. Okay. I realize that it must be painful to watch me do this sometimes. Okay, so this should be a nice little, yeah, okay, that's what I wanted. Okay. Now we can come in, and what we could also do is we could show that gray image that we made. And so what we could do here is we could come in and we could say do a CV2.IM show, and this time I'm going to say me in gray for the window name, and then I'm going to show gray. All right. Now I'm going to need to move that out of the way, so I'm going to do CV2.move window. Okay, and then I'm going to go which one? Me in gray. All right, and then where do I want to move it? Well, I think this is row column, I think, so I want to stay at row 0, and then the column we'll put, like, let's say 350. So let's put it at 0, 350. Now, what's confusing in OpenCV, that if you're dealing with a matrix, it's always row and then column, row, comma, column. But if you're dealing with math, it is X, comma, Y. So about half the time you're going to guess this wrong, because sometimes it wants row, comma, column, and sometimes it wants X, comma, Y. And so we'll just try this and see if it works. And of course I guessed it wrong, but you can't see it, but let's fix that. So I went row, column, and it wanted X, Y. So let's go 350, comma, 0. So I'm sorry, this would be X, comma, Y, I do believe. Yeah, boom. Okay. So you see, I converted it. Okay, I converted it and I'm showing it. Now, also just one other little thing that all of a sudden now, what you got to see is there's nothing mysterious about this frame, and there's nothing mysterious about this gray. Now, I do need to do one little thing here. I need to convert it back. So when I go from color to gray, it flattens the image. So each pixel is not 3 data points for red, green, blue. It is 1 data point, which is gray. So it flattened the array to only have 1 number at each row and column. It has 1 number, which is great. So I want to convert it back to color. Now the color is lost, but I just want to get the matrix back to, you know, a 3 numbers in that in each pixel, and it'll make sense in a minute while I'm doing this. It's .cvt color, and then this time I'm going to work on gray, and this time I'm going to do cv2 dot, and I'm going to do gray to BGR. And that's the other kind of quirky thing about OpenCV. It goes blue, green, red. It goes blue, green, red. Normally you think of red, green, blue. Okay, so this is still going to be a gray scale image, but there's going to be 3 data points for each pixel. So let's go ahead and do this. Oh, and what did we do? Gray to... Okay, somebody tell me what I did wrong. Oh, I forgot color. All right, you guys, I'm sure were yelling at me. Okay, so now let's try it. I think this one will work. Okay, there it is. So you see, the gray image is still gray. It's just in a color format, but the numbers are the same in those 3 positions, so it still stays gray. But let me show you why I did that, okay? So what I could do now is I could come in, and what you got to see is there's nothing magical about gray or frame. All it is an array. Okay, it's a matrix, right? It's an array. If you've done Arduino, if you've done Python, you know about arrays. It is a 2-dimensional array where you have rows and you have columns. It is just a data array. Well, I can go in and just manipulate that data. So let's say I could say gray, and I could treat it now where I'm going to put an index in there, okay? And now, of course, I'm not sure. Let's see. I think this is going to be row, comma, column. And so I'm going to go from, let's say, 120 to 140. So I'm taking row 120 to row 140, and then I'm going to take column 85. That should be a comma. I'm going to take column 85 to 115. I'm just kind of winging it here. I should have tried these numbers before then. So I'm taking in that gray, I'm taking row 120 to row 140, and remember there's 320 rows. There's 320 columns. Okay, 320 columns. I'm going 120, 140, and then 85 to 115. So I'm taking that data in those ranges, and I'm going to say that that is equal to what? The color one, frame. Okay, and then I want to use that same image because those two images are the same size. And I'm sure I butchered these ranges because I'm getting rows and columns mixed up. But let's do this and just see. Hopefully it's not completely off the screen. Okay, there it is. You see that little, do you see that little box there? What I did was I ran and I stole that little piece over here. I stole that little piece over here on the color one, and I went and I put it on the gray one. Okay, so you see how you can start manipulating? You can start manipulating your image, just treating it like a data array. I'm just treating it like a data array. And so let's see. I think it would make sense if that was a little bit bigger. And so I went 120 to 140. And then I went 85 to 115. Let's say I went 160, and then let's say I went 130. And so that's going to be much bigger. And I've got to remember not to just kill the program. I've got to remember to be good and quit out of it. Okay, now let's take it. This should be a bigger segment that I'm stealing and moving over. Did not like that at all. 120, I got to do this both places. Copy, paste. All right, let's see. Man, it doesn't like this. What did I do wrong? 120 to 160, 85 to 130. Hey, thank you, Mr. Nimbus. Boom. Man, you guys are really, really being very generous. Philippe. All right. I'm sorry, Philippe. Yes, 2 brackets. All right. Did a little sloppy copying and pasting. All right. There. So you see there is a larger little window. Okay. A larger little color window. Now you could imagine you could make this a bouncing box that would move across the screen, the part that was colored. You could imagine that you could find the face and you could black the face out. You could imagine you could find the face and borrow a different face and put, you see, there's all types of things you can do, because what is gray? Gray is just a matrix. It's a 2-dimensional matrix with 320 rows. No, 300. I keep saying it. You know what I need to do? I need to put them in the right order, and then I'll say it right. Okay. There. It has 180 rows and 320 columns. 180 rows, 320 columns. And so if I wanted to look at an individual pixel, in fact, I could say print, and I could print from the matrix gray. I want to print from the matrix gray. I want to print the pixel. I could print an individual pixel, and I could print the pixel, let's say 120. Okay, and then the pixel 85, like that. And this is just going to print 3 numbers. It's going to be the 3 numbers that are at that position, if I'm thinking about this right. And I'm probably gonna mess up, but let's see if this will work. I always get these ideas on the fly to do things. Okay, Mr. Nimbus says that he was a litter picker, met a man with the library reading pie books. He told me about you. Learning from you, I got into uni without the grades. Hey, wow. Okay, Mr. Nimbus, that is the kind of good news I like to hear. I like to hear that people actually not only enjoy these lessons, but are bettering themselves with these lessons. That's a huge encouragement. Love to hear that. Okay, so let's see if we can actually do this now and see what kind of crazy thing I did here. Okay, so you see, look at this, and let me make sure that you can see this over here, which, yeah, you can. Do you see how I am printing out an array of three numbers. And what that is you see how it's changing because the image is changing. That is the R, the G, and the B value of 1 pixel in gray. It is the pixel that is at row 120 and column 85. Now I'm going to try this because I think that if I make this like, let's go in the gray region, which would be like, let's just say row 5, column 5, that's in the gray region. We're still going to see three numbers, okay? But you see how they're the same? Because a gray image, if R and G and B are the same, you get gray. And if it is a 255, 255, 255, you're going to get white. If it's 000, you're going to get black. And 100, 100, 100 is about halfway. And you can see up here, this would be about 55, that pixel there. It's kind of halfway between black and white. So it sort of makes sense. Why am I doing this? I want you guys to see that there is nothing mysterious about an image. An image, you grab it from the camera and then it's just good old-fashioned data. It's numbers. You have a row index, you have a column index. So you have R, C, row, column gives you a pixel. That pixel has three numbers, the red value, the green value, and the blue value. But in the crazy world of OpenCV, the first number is blue, the second number is green, and the third number is red. BGR, blue, green, red. Or in this case, we set them all the same, so it is gray. Is this making sense? How does machine vision different from computer vision? Machine vision cameras are much more expensive. Well, I think a machine vision camera has some of the intelligence and image processing built in to where what we're doing with computer vision, you're just taking a cheap webcam and you're doing it in the computer. Somebody asked what webcam I have. I'll give you some links later on, so you guys, if you want to do this, you'll have the same camera. I have one of the Logitech webcams. You can buy cheaper ones, but the thing is, because we want to go in and we want to send commands to the camera, we want to work with it, it's good to use one that we know will work with OpenCV. Okay, sir, please recon the laptop for good programming. Please what? Not sure what you're asking there, Mapari. Could be interesting for space application, tracking celestial bodies and Doppler effects. Yeah, there is all types of things. You see, I like doing this just with camera images, just like video images, because you get so much data. The data is so easy and it's so interesting to do. But artificial intelligence is not just images. You can get all types of data and do different types of cool things with it. Okay, stacking images. Yeah, you can stack images. You could imagine that I could create like a mask around myself, and then I could get rid of everything that isn't part of the mask. And I could create the mask intelligently based on the image, and then I could take the background and I could put a different background in. And so there's all types of interesting things that you can do. Okay, what do I think about resin 3D printers? I don't think I like them very much because I don't like all that chemical in my house, just all that stinky chemical. And then it's like you got to get the thing and it's all goopy, and then you've got to like use acetone to clean it. And it's just like, I don't like chemicals that much. So even the, what do you call it, the ones where you have the real, like, what is it? I cannot remember the name of the cable that you use to print with a normal 3D printer. But even when you're using those normal 3D printers, as you're melting that cord that becomes your object, it puts off fumes, and you can really smell those fumes in the room. So I don't even like having one of those things in my room because it's generating all those fumes. And sometimes the prints take 12 hours, 24 hours, 36 hours. So I don't want to sit and breathe that fume all the time. So I would rather have the one with the normal cable to generate the what is that stuff called? The filament. The normal filament. I would rather use one of those than a resin one. But even that outgasses some fumes off of that. I'll tell you, I have had probably 4 3D printers, and those things really, really, really broke my heart. I started out with the MakerBot, and I got 2 good prints out of it, and then for the next 3 years, it was constantly broken. Then I got a really, really expensive, like a $5,000 raised 3D printer, and it would make beautiful prints when it was working. But it's like either you don't stick to the build plate, or you stick to the build plate so firmly that you can't get the thing off the build plate, and you're constantly tweaking. I think probably the best 3D printer I ever had was the Prusa, and it seemed to work kind of reliably. But I might at some point give 3D printing another try. Okay, Philippe says he puts the printers in the garage because of the air. Yeah, I would put it in a place that I didn't live and sit there and breathe it all the time. Philippe, what type of 3D printer do you have? Maybe you could give us a little bit of a guidance here on what you're doing. But part of the problem was I was a high school teacher, and I taught freshmen, sophomore, junior, seniors. There was a lot of students in there, and there were always students wanting to come in and play with the 3D printer. Well, some guy would come in and he would print something, and then like he would then get it all put back together. Then somebody else would come in and break it and leave it. And so maybe I would enjoy 3D printers a little more if it was just me and a printer and me working with the printer, and not me having to be the maintenance man for 20 people breaking it and me fixing it. And I'll be honest, I finally just gave up on 3D printing in high school just because the students did not have the discipline that if they broke it, to sit there and take the 2 days to fix it. If it was working, they had fun designing and printing, but they didn't want to go in and fix it. So let's see. Philippe says he started with the 3D Walks 1. Okay, I'm not familiar with that one, but I will look it up. Okay, so Sunil is saying, any plans for a studio tour? Let me get my studio set up. I am in a kind of in an interim facility right now, and when I get my real studio set up, I'll give you guys a tour. It's gonna be nice. I got some good equipment over here. I'll get it all put together, and I will show you guys. So I'm not really. I've kind of got a bad taste in my mouth for 3D printing, but at some point I would like to go back and redo those Fusion 360 lessons that I did, and then maybe have it centered on 3D printing. And maybe if I just had my own printer without 20 people using it, maybe I could, try one more time. But like I say, I've sort of kind of gotten burned a number of times on 3D printers. There are so many types now, 5-axis printers, which rotate about the circularly, so no need for supports. That would be very exciting. Also, the last version of the Prusa kind of had a self-leveling base, which did make the sticking down a little bit easier. I do still find the clogging nozzles a very frustrating thing, where you got to take it apart, and it seemed like what I always felt like, once one of those nozzles became clogged, I could clean it and put it back together, but it never seemed to kind of like really be completely clean. And so clogged nozzles was one of the things that sort of made me end up not wanting to do 3D printing anymore. Okay, guys, I've done a lot of talking here. You need to let me know, is this something that you're going to be interested in? If I did a set of lessons on artificial intelligence for everyone based on OpenCV and based on Python, would you guys want to do it? And then if I did it, should I do them in parallel with my Visual Python lessons and my Arduino Visual Python lessons, or should I do them sequentially, like get through Visual Python, get through Arduino with Visual Python, and then do artificial intelligence? Or should I have parallel threads going along? Okay, got some people saying yes, got some people saying yes. Philippe says very interested. Oh, carbon fiber, yeah, I believe you're right that you can sort of burn that stuff in there. Okay, yep, interested. Got some people saying parallel, absolutely, sure, love to learn, absolutely. Okay, it seems like we have got some interest there, maybe enough for me to do. I'm still trying to look and see. Okay, Mapuri says sequentially, parallel. Okay, it seems like we're probably getting more people saying parallel. It seems like we're probably seeing more people say parallel. Okay, and I guess if you wanted sequential, you could always do them sequentially if I offered them in parallel. Okay, you could always do it in parallel. Cap says do it in parallel. Okay, so that might be reasonable. Let me check in and see on something here. See where we are here. Looks like we are coming in at about approaching an hour, and so I'll take a couple of more. Okay, guys, how was let me ask you this. I'm getting a warning. I'm getting a warning from YouTube. How was the stream? I tried to stream at 1080p. Was it choppy, and was I breaking up, and was it getting glitchy, or did it come through pretty smooth? Let me know whether I was trying to do too much. I could drop back to 720p if my internet was not streaming. Okay, Ritwick says no problems. A couple of more guys give me stream was great, stream was good. Okay, it looks like I was able to sustain the 1080p at 30 frames per second. To me, there's no reason to try 60 frames per second at all. There's no reason to try to do that. So I'll try to do the 1080 at the 1080p at 30 frames per second, because it is, when you're trying to read the text, it's a little bit sharper than the 720. So I will do that. There were 2 pauses for about 5 minutes ago, but everything else seemed good. Okay, it seemed like a couple of people maybe got some some pauses. But if it's good enough, I will try to keep doing the 1080, and then if it turns out to be a problem, at some point we'll drop back to 720. Also, I'm hoping once I'm not feeding you 2 microphones that the audio's okay. This room has a tile floor and concrete walls, and so I noticed when I re-listened to a couple of my first recordings, there was a lot of echo. So I've moved pillows, and I moved cushions, and I moved a lot of cloth in here to try to take the echo down. So let me know, how was the audio on this? Was the audio okay, or what are the suggestions you guys would have for me on the audio? You know, I want to maintain good production quality, and I'm trying to sort of get my studio tuned in here. Audio, okay, audio is good. Yeah, Cap, you know, I've had to, for certain things, I've had to use a VPN, and I've noticed for the last week using a VPN going through South Africa, it seems like you guys are having limited internet connection down there. Okay. Audio is fine, audio fine. Okay, guys, I appreciate the feedback. All right, we've been at this a little bit over an hour. I try to cut these things off at an hour. Really appreciate you guys tuning in. Remember, it helps me with the algorithms if you give me a thumbs up. And also, leave me your suggestions in the comments down below, because it's kind of hard for me to keep track of all the chats. Leave a comment down below. If you're interested in me doing artificial intelligence for everyone, leave me a comment. Should I do them sequentially, or should I do them in parallel? Leave me ideas of what you would like me to do, because it's a lot of work for me to make these video series. And if I'm going to do them, I want to make sure I'm doing something you guys are interested in. So this is your chance to give me feedback. I will listen. I'll read every single comment. Okay, guys, really appreciate your encouragement. Appreciate the help. Appreciate the comments. If you haven't subscribed, subscribe to the channel. I'm going to let you guys go. This is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.